So let's do with paper 2 what we did with paper 1, where we'll concentrate on the questions that you guys struggled with rather than spending time doing stuff that you already know how to do. So theoretically, question 1, we should have all been okay with that particular question. Is there anybody who wants me, thank you, Terry Road. Is there anybody who wants me to go through question 1, or are we okay with that? Okay, so Tristan says no. Okay, Barley, you want 1.3. Okay, I understand why. Lesedi, go for it. You can unmute and speak.
Hi, ma'am.
Hello, how are you?
I'm good, thanks. And yourself?
I'm fine, thanks, Lesedi.
Ma'am, may I please get 1.3 as well?
Okay, all right, no problem. Okay, so I see there's a couple of you that are asking about 1.3. Okay, so in order to answer 1.3, we also need 1.2. So what you should have calculated in 1.2, sorry, I mean 1.1, you should have calculated the equation of the least squares regression line for Dalvin's results. Did you get y equals minus 10,74x plus 122,67? Did you get that answer? So the answer from here is necessary. So it was y equals 122,67 minus 10,74. Did you get that answer? Yes. Okay. All right. You got that as well, Letu. Excellent. Okay, so that's what you need in order to be able to answer this particular question, because it tells us here that Chumani results gave a least squares regression line with equation 116,79 minus 5,61x. All right, so this question is an interpretation question based off of the idea that the fitter you are, the quicker your pulse rate returns to normal. So your pulse rate will return to normal more quickly if the gradient of the line is steeper. Okay, so that means that this gradient over here, although both gradients are negative, this gradient is the steeper of the two, and that's why it will be Dalvin. He will be fitter than Chumani. So the answer to this is Dalvin, and it is because the gradient is steeper than Chumani's. Okay, so 2 marks on that. 1 mark for Dalvin and on the other mark for the reason. Is everybody okay with 1.3? Lesedi, Lebogang, Tristan. Does that make sense? Okay, you actually guessed it right. Okay, there we go. All right, so as I said, it's based off the fact that the fitter you are, the quicker your pulse rate returns to normal. So Dalvin's will return to normal faster because the gradient is steeper. Okay, all right, cool. Let's go on and have a look at question 2 then. Anybody want me to do question 2? Let you know, not in this particular case, no. No, I wouldn't have thought so. I think you would need to just look at the gradient. Okay, but it's really nice. I love the fact that you always ask, is there another way to do this question? It's such an important thing to be able to look at things in a number of different ways. It just helps to deepen our understanding. Okay, so again, question 2.3. So again, we need the graph in order to be able to answer this particular question. So I'll tell you what I'm going to do. I'm going to take a picture of it just very quickly and pop it onto the screen instead of drawing it, because that's just going to take much longer. And then I can show you where the answer comes from. So just give me 1 second, Matrix. I'm just, oopsie, just taking a picture. Where are we now? There we are. Okay, so there we go. You'll see this on the memo that gets sent to you. This is the memo that I was sent. Speaking of which, when I looked at the memo, I noticed there was something missing in one of the questions. So yeah, when we get to the Euclidean geometry, I must just remind you about that. So 90 learners wrote a test out of 60. Okay, so the cumulative frequency represents the number of learners. Then when they say to us who obtained a mark above 45 out of 60, so what we would need to do is we would need to go and find 45. So I'm going to do this in orange. You would do this using your ruler. And 45 is going to be somewhere in the middle. So we would draw, come on, ruler. We would draw a straight line. That's not a straight line, but anyway, let me just move it over a little bit. We would draw a straight line going up from 45. Okay. It's just, okay. So this is just going to give us an estimate. Sorry, I wanted to make it straight, but it's not cooperating. And then we would go straight across. So we would go straight across here. It's about there, maybe a little bit lower. Always try and move it down a smidge. Okay, so we would find 45 on the x-axis. We go up, we hit our graph, and we then read off on the left-hand side over here. So you would kind of have to estimate, a good estimate, obviously, a reasonable estimate of what you think that number is. So I can see it's 75, so I'd say maybe 73, 74, obviously depending on how you've drawn it. This purple line is quite thick. So it looks about 73 or 74. So the people that are above this going up to 90, these are the ones that got over 75. So what we would do, sorry, over 45. So what we would do is we'd say 90 minus 74 or 90 minus 73, and that's how we would calculate that. All right, so we would use our graph to get this answer. Yes, they do. They do, Lesedi. And normally it's about one either way on something like this. So they probably would have accepted 75 and they'll accept 73 as well. So yes, whenever you have to estimate something using a graph, there will always be a little bit of leeway. Okay. Everybody happy with how we would answer that particular question? Right. So 1 mark you should show that you've used your graph. So you should indicate on the graph these orange lines that I have used, and then you should write down your answer. Okay, for the 2 marks for that particular question. Okay, everybody's happy with question 2. Question 3, and again, if we do questions sort of down at the bottom, we're going to need stuff from up the top. Question 3, anything here you'd like me to go through with you? So Tristan says no thanks. Okay. Mbali 3.5. Lebogang says no. Yeah, this was really sort of pretty straightforward. Okay. Sinikwe 3. Okay, so guys, I'm just getting asked for 3.2, 3.5, and 3.6. So let's just quickly do those. In 3.2, when they ask you about an angle of inclination, you need to use that formula tan theta equals m. That's how you would calculate the angle of inclination from the gradient of the line. Okay, so we would need the gradient of the line from 3.1. So in 3.1, you should have calculated the gradient of the line to be -2. So what you would do here is you would then say tan theta is equal to -2. Because the gradient of the line is negative, that angle theta is going to be an obtuse angle. So you first have to calculate your reference angle and then subtract it from 180. So this is a place where a lot of learners lose marks. So it's a common exam error. You need to write that it is your PAA or your reference angle. So you go shift tan, and that should give you 63,43. But you mustn't write that this is theta because it's not. Okay, and then you would say theta is going to be equal to 180 minus 63,43. And then you'd get your 116,57. Okay. All right. And then some P says 3.7. So that's 3.2, 1 mark for subbing in, and then the other mark there on your answer. Okay, so just checking here, that's 3.2, 3.5, 3.6, 3.7. Okay, so in 3.5, let's do that next. And again, of course, we need stuff that we have already calculated. They want us to determine the equation of the line parallel to BC passing through A. So if it's parallel to BC, it has the same gradient as BC. So we need our answer again from 3.1. So this line has the equation y equals minus 2x plus c. It has the same gradient as BC. And then all we need to do is sub in A. So we would sub in point A with coordinates minus 1 and 1. So we would say 1 is equal to -2 into -1 plus c. So that means that c is going to be equal to, this would be +2, so we would need to take away 2. So it would be that. And again, if they ask you for an equation, write the equation afterwards, because you don't know where in the paper they're going to penalize you for not writing the answer that they want. Okay, so you should have ended up with that. Okay. No, you don't, Cheslin. It's not necessary. It's not necessary to state the gradients are the same. Okay, so there would be a mark for the same gradient, a mark for subbing in, and then here a mark on your answer. I see in the memo as well, they've made a little mistake here. They've got the wrong y-intercept, but I think ours is correct. Okay, let's go on to question 3.6. Now, this is also a really important concept, and I'm sure that they would probably end up asking you something like this, although they might not say show that a triangle is right-angled, but they probably will ask you to prove that lines are perpendicular to one another. Okay, and that means exactly the same thing. How you set this question out, like with all proving questions, is so important. You can't write what you're trying to prove first. You first got to do the calculations and then make a deduction based off of that. Okay, so we see that a lot in this question where you're asked to prove that two lines are perpendicular. And the other place where it happens a lot is if you're asked to prove that events are independent of one another. You mustn't write the rule first. The rule is the deduction. Okay, so we need gradient. So what do we already have? Without going and creating new information, let's see what we've already got. So we suspect that the right angle is at B. We've already got the gradient of BC. So we're not going to recalculate that because that would be a waste of time. So we've got the gradient of BC. We know that it's equal to -2. That comes from question 3.1. So now we need the gradient of AB. So now we're going to go and sub in. So the gradient of AB, and tell them what you're calculating. Tell them that this is the gradient of BC and this is the gradient of AB, because then they can understand that, or the person marking your work can see that you understand what you are doing. Okay. So change in gradient, so that would be 4 minus 1 over 5 plus 1. And what we would be hoping for is an answer of a half. So let's see if we get that. That gives us 3. This gives us 6. So we get 1 over 2. Okay, so now we know that it's working correctly. So underneath that, let's just move these down a little bit. So now you can say, all right, -2 times a half is -1. So now your deduction. So that means that the gradient of BC times the gradient of AB is equal to -1. That's, you do not write that first. That is what you're trying to prove. Okay, so therefore, B is equal to, oh, sorry, before I do that, so therefore, BC is perpendicular to AB, therefore ABC is right angled. Okay, so this was out of 3 marks. So your conclusion would be 1 mark. The product of the gradients, and then here probably subbing into gradient formula. Okay, question 3.7. They've asked us to determine the area of triangle ABC. So now that you know that it is right angled and you know that the right angle is over here, you don't need to use the area rule to calculate the area of this triangle. You can just do what we've done from grade 8, half base times height. That means you need the length of AB and you need the length of BC, because these are the, sorry, it's just hard for me to draw on the side like that. There we go. Okay, so you need the two sides that are adjacent the right angle. If you treat BC as the base, AB is the height, or if you treat AB as the base, then BC is the height. So let's go and have a look what other information we've got. Yes, look here in 3.4, we've already got the length of AB. All right, so I'm just going to write that down. You wouldn't obviously need to write that again, but because I'm not doing this from the beginning. So the length of AB, it ended up being root 45. Did you guys get that? And now we would need the length of BC. So let's just sub into distance formula, 3 root 5. Yes, that is 3 root 5. Okay, so it's our change in our x's, so it's going to be 5 minus 8 squared. And our changes in y squared. So that is going to be 4 plus 2. So when we sub into our calculators, I'm getting 3 root 5 as well. Okay, so this is also equal to 3 root 5. Okay, so therefore, the area of triangle ABC is going to be half base 3 root 5 times height 3 root 5. Okay. And that means you should have got an area of 22,5 units squared. Not that you need to write that, but it just means you show that you understand that you're working with area. Okay, so 3 marks here. Has to be a mark on the answer, has to be a mark for subbing in, and then I guess there has to be a mark for getting the distance of BC. Okay, everybody happy with question 3.7? All right, let's move on then. And excuse me, let's talk about question number 4. Anything from question 4 that you'd like me to go through? Just make it a little bit bigger. There we go. Okay, so Cheslin says 4.3 and 4.5. Lesedi, can we do the whole thing? iPhone, can we do the whole thing? 4.5, 4.5. Okay, so I expected 4.5. Okay, so I tell you what, let's just very quickly, because there were 2 requests to do it from the beginning. So let's just quickly work through this. In 4.1, okay, and I'm gonna do the beginning bits quite fast, okay? They want us to determine the coordinates at the center of the circle. So you need to take your, okay, Chiriro says the whole question as well. You need to take your equation, which is this one over here, and you're going to have to complete the square in order to get the coordinates at the center. So what I do is this, is I say x squared, and I put my plus 3x over there, and then I leave a space. And then I say plus y squared, and I put my minus 4 over there, and I'm going to take my 1 over to the other side. And now I'm going to go through the process of completing the square. So remember, when you complete the square, you take half of your b term. So this would be 3. So that would give us 3 over 2. And now we need to square it, and that would be 9 over 4. So I'm going to add in 9 over 4 on the left. So I've got to add in 9 over 4 on the right-hand side as well. And then I'm going to repeat the process for y. So I'm going to take half of -4, which gives me -2. And then I've got to take -2, and I have to square it, and that's 4. So now I'm going to add 4 to the left. I'm going to add 4 to the right-hand side. So this gives us perfect square trinomials. There's our perfect square trinomial in terms of x. There's our perfect square trinomial in terms of y. Okay, so in brackets here, we're going to have x plus 3 over 2 squared. And over here, we're going to have y minus 2 squared, and that's going to be equal to the right-hand side. So the right-hand side, the value of the right-hand side is going to be 29 over 4. Did you guys get that? So the coordinates at the center, C, we change the sign. So it would be -3 over 2 and +2. And that makes sense because we can see that point C is in the second quadrant. So we were expecting a -x and a +y. All right, so that was out of 5. Don't know that it would be out of that many marks in your exam, but it doesn't matter. So there has to be a mark for completing the square. There would have to be a mark for getting it into center radius form, and then there has to be a mark on your answer. Perhaps there was a mark on each like this. I don't know, another mark on what you do to the left, you do to the right. It's a little bit too many marks, but as I say, probably out of 3 rather than out of 5. Okay, question 4.2, calculate the length of the diameter. So you know the length of the radius squared. Remember everything that you have on the right-hand side here. So what I'm highlighting in yellow, that's r squared, isn't it? Okay, so r squared is equal to 29 over 4. So that means that the length of the radius is going to be the square root of that. So it would be root 29 over 2. And the diameter is double that. So the diameter is 2 times root 29 over 2. You would obviously write underneath. Sorry, I'm writing next to it. I'm just trying to fit everything onto the screen. And that would give us root 29. Okay. Next question, 4.3. They told us if the equation of the circle is given as this, so now we know that we've got it right, determine the equation of the tangent to the circle at E. So here is the tangent, and we know that every radius is perpendicular to its tangent. So now what we need are coordinates either at E, we've got the coordinates at C if we want to work out the gradient of the radius, but they haven't given us that. They haven't given us any coordinates at E. So let's go and look at the next piece of information that they give us. All right, and that's where the answer is going to come from. So here they tell us that the equation of DE is this. So what we will need to do here is we'll first need to put that into standard form so that we can get the gradient of line DE. So I'm just going to do this here on the side, 4.3, and just, again, make sure your numbering is perfect. If you write 4.3 and you're doing question 4.4, they are not going to correct the numbering for you. Okay, so make sure your numbering is perfect the whole way through. So they give us the equation 5y minus 2x minus 13 equals 0. So making y the subject and moving the other terms over to the other side, we now need to divide through by 5. So this gives us 2 over 5x plus 13 over 5. And it's this that we're after. Okay, we want this piece of information. This is the gradient of line DE. Okay, so what we would say now is that DE is perpendicular to, okay, it doesn't have a name. So tell you what, let's call that F over there. DE is perpendicular to AF because your radius is always perpendicular to your tangent and you are expected to write that. Okay, so therefore the gradient of EF is going to be equal to negative 5 over 2. So you are allowed to write that down. Okay. And now okay, you know what we could do here? We need the coordinates at E, all right, in order to be able to complete this, because we've got the gradient, we need to calculate the C value. So what I'm going to do now, in order to get the coordinates at E, is I'm going to use, I was going to use midpoint formula. But you don't have the coordinates at D. Let's see how many marks this is out. Okay, so the coordinates at D is the next question. So this is out of 4 marks. Oh, hang on a second. Sorry. This is why it's so important to read all the information that's given to you. Okay, so sorry, I'm going backwards and forwards and backwards and forwards. There we go. All right, so look here, guys. They've given us the coordinates at E over there. Sorry, you know, on the screen, it's always a little bit difficult because you're going up, down, left, right, whatever the case is. I should have actually read all the information first. And that's why you should read all the information first, because if you don't, then you end up doing exactly what I'm doing now, where you're scrambling to try and find information that you need that's actually already given. And it's one of my rules is always read the information that's given, and you can now see why it was silly of me not to do that. Okay, so we've got the coordinates at E. Normally what they would do is that anything that is given to you, they generally should actually put on the diagram. Okay, so sometimes they don't in Euclidean geometry, sometimes they don't, but generally speaking, if information is given to us, it should be on the diagram. Okay, never mind. So now it's easy. All we need to do is go and sub in the coordinates of E, which are 1 and 3. So the equation of this line, it's the line y equals minus 5 over 2x plus c. And now we can put our 3 here, our 1 there, solve for C. C ends up being 11 over 2. Did you guys get that? And therefore the equation of this line, it's the line y equals minus 5 over 2x plus 11 over 2. There we go. Cool. Msomi, could you have found the gradient of MCE? MCE? Yeah, I suppose you could have. It would have, you would have ended up with the gradient of EF being the same. All right. Okie doke. So that was out of 4 marks. Let's just see where they would give us our marks for something like that. So there would have to be a mark for rearranging. There would have to be a mark on getting the gradient of EF, subbing, oh, sorry, beg your pardon, put it on the wrong line, subbing that in, and then on our answer like so. Okie dokes. Let's go back and go and see what else we haven't done here. Where are we? 4.4 now. Okay, write down the coordinates of D. So now that we've got the coordinates at, well, not that now, but now we have the coordinates at E, we have the coordinates at C. Let's just pop those onto the screen. We know that that's -3/2, and we know that that's 2. Now we can use midpoint formula. All right, so for question 4.4, we have got the x coordinate at D plus the x coordinate at E over 2. Sorry, yes, over 2, and that's equal to the x coordinate at the center, which is -3/2. So because the denominators are the same, we can drop the denominator, and then we can just take the 1 over to the other side. So the x coordinate at D would be equal to -4. And then we can do exactly the same thing with the y coordinate. So we've got the y coordinate at D plus the y coordinate at E over 2. And this will be equal to 2 over here. Cross multiply. Sorry, I'm kind of squashing it in a little bit. So I'll tell you what I'm going to do. I'm just going to rub that out because we know where that comes from. And cross multiply 2 with 2. And then it would be the y at D is 2 times 2, which is 4 minus 3. So the y coordinate at D would be equal to 1. So the coordinates at D are -4 and 1. Okay, so that is the sort of easy work on the circle over and done with. Now we need to worry about question 4.5. Is everybody happy so far? Can I start 4.5? Yes, yes. Thank you, Tristan. Thank you, Lebogang. All right. So when they talk about a second circle and they ask us to determine whether the 2 circles intersect each other, we need to know, we need to have learnt an important piece of information. And it all hinges off of this. So what I'm going to do, tell you what, I'm going to write on the side here. I'm just going to scooch over just a little bit. Let's create a bit more space. Okay, so if 2 circles do not intersect one another, the distance between their centers, D, is going to be greater than the sum of their radii. If 2 circles touch one another and are tangents, sorry, I'm drawing terrible circles here, then what you will find is that the distance between their centers is exactly equal to the sum of their radii. And if 2 circles intersect one another more than once, what you will find is that the distance between their centers is smaller than the, is smaller than the sum of their radii. So this is something that your teachers should have taught you in class and discussed with you. Is this something that sounds familiar now? Letu says yes. Tristan says yes, yes, yes. Okay, so we're getting a few yeses coming through. Cool. So this is what we need to test. And again, it's like when we are trying to prove that events are independent, or we are trying to prove that lines are perpendicular. We don't know the outcome. So we can't say that the left-hand side is equal to the right-hand side, because we don't know which one of these three conditions is actually true for this situation, because here they didn't say prove that the circles touch one another in one place. They didn't say that they did intersect. They didn't say that. It just said determine whether the two circles intersect each other. So we actually do not know whether the circles intersect at all. So we have to split the left and the right-hand side up. In one calculation, we're going to calculate the distance between their centers. In the other calculation, we're going to calculate the sum of the radii. Okay, and then based off of our answers, we can then decide which one of these categories it falls into. Okay, so now we want the distance between the centers. So we know that circle C has a center of -3/2 and 2. The other circle they gave to us already in center radius form. The coordinates at the center of that circle are 3 and 4. So let's call that T, and the coordinates there are 3 and 4. So now we want to use distance formula. Our change in x's squared plus our change in y squared. And that means that the distance between the centers of these two circles is, are you getting 4,92? Sorry, I know you guys are probably writing as well as listening. Hey, boo, what did I do? Oh, I forgot to put it in brackets. That's why. Sorry, the calculator don't like it if you open a bracket and you don't close it, it says syntax error. It's better. Okay, so I'm getting root 97/2 is my answer, which is 4,92. Yes. Okay, you guys are all getting the same thing. Okay, and now when we go back and we look at the radii, in the circle that they gave us, r squared was equal to 9. So that if r squared is equal to 9, it means the radius of that circle is 3. Let's call our other radius r. And oh yeah, I went and I rubbed it out, didn't I? But we know that r squared is root 29 over, or sorry, r is root 29 over 2. We know that already. So that's root 29 over 2. And now what we want to do is we want to work out the value of r plus r. So again, you would be writing underneath. You wouldn't necessarily be writing next to it. I'm just doing it so that we can fit it onto the screen. And now we're going to work out what r plus r is. Okay, so root 29 over 2 plus our 4.92 gives us the sum of the radii is 7,61. Okay, so what we can see here is that the d value, we've got the distance between the centers, is much smaller than the sum of the radii. So the distance between the centers is smaller than the sum of the radii. So that means it's condition number 3. Okay, so therefore the circles intersect twice. All right, and that's how we would do that particular question. Okay, so the sum of the radii is we're working out the radius of the one circle and we're adding it to the radius of the other circle. So if you have a look, the circle they gave us, they told us that this r squared was equal to 9. So taking the square root, that's why we got 3. We know what our other radius is because we've actually worked with that in question 4.2 when they asked us to calculate the diameter of the circle. So it's these two numbers that we are adding together. So our r plus r, this value over here, is our 3 plus our root 29 over 2. I'm adding the two radii together. Okay, and then the sum of the radii together are greater than the distance between the centers. Okay, so if the distance between the centers is smaller than the sum of the radii, it means you don't get 7,61. All right. Is everybody else getting 7,61? Did I maybe make a mistake? Sorry, I could have done. Let me just double check my. Oh, I know what I did. Sorry. It's 3 plus. Sorry, that's root 29 over 2. Sorry, guys. Sorry, I made a mistake there. My adding was faulty. I beg your pardon. Okay. We get 5,69. Sorry. Yeah, I got 5,692. Sorry, I don't know. I added, for some reason, I added the radius to this distance over here. I just stopped thinking. I'm sorry. Okay, so the sum of the radii is 5,69. Fortunately, our answer is still correct. It is greater than the distance between the centers. So that means that the circles would still intersect twice. Okay. So subbing in here, getting that, getting this, there, and then our conclusion. All right. Are we all happy with question 4.5? There, that was. We all good. Oh, good. Lovely. Nice. Okay. Apart from my adding errors, but there we go. Okay. Let's have a look. I also stuck this question on just to give us something else to work on if we needed it. Now, the trig. Okay, so this paper does not, for some reason, I don't know why, it contains a trig graph, but it doesn't have any 3D trig in it. So you will definitely get a 3D trig question as well that you will have to answer. Having a look at the general trig, is there anything here that you want me to go through? In question 5. 5.2. All right, sure, not a problem. Okay, so let's start there. So question 5.2. Let's just come in. Let's just move that right over. Okay. And let's do 5.2 over here. Okay. So they give us the sine of 123 over the cos of 33 plus cos minus x times tan 180 minus x times, let's just scooch over a little bit, times the sine of 360 plus x. It's part of a different question. And let's get rid of that. Okay. So if we have a look at the first term, when we see the sign 123, because that is, all right, Mbalentli, not a problem, because that angle is obtuse, we have to use reduction formulae. So 123 means that we are in quadrant number 2. So we would be using the reduction formula 180 minus. Right, and because sine theta is positive in quadrant 2, it's going to reduce to something that's positive. So this is going to reduce to positive sine 57. And with trig, we've got to be super careful because every time we use a reduction formula or an identity, we have to write it, okay, before proceeding with our question. So cos minus x is the fourth quadrant. So this is going to become positive cos x. Tan 180 minus theta is the second quadrant. So this is going to be negative tan x, and I must write that before using my tan identity. And then the last part was times sine 360 plus x. So 360 plus x means I've done a full circle, and then I've gone back into quadrant number 1. So 360 plus x is going to reduce to positive sine x. Okay, or you could just subtract 360. Okay, but it would end up being in quadrant number 1. Now, the first term, that's a very important concept. If we look at the numbers, 57 and 33, they add up to 90. So we're dealing with cofunctions. So that means that the cos of 33 is equal to the sine of 57. So we can either write our answer in terms of sine or in terms of cos, but these two are equal to one another because they are co-ratios. So I'm going to write the cos of 33 as the sine of 57. And then in this line over here, I'm going to apply my tan identity. So that's minus sine x over cos x. Remember, if you've got negative tan x, it's not negative sine x over negative cos x. Only either the numerator or the denominator is positive. It's not both numerator and denominator that are negative, sorry. Okay, so only one of them is negative. The other one is positive times sine x. So here, these cancel. That's going to become 1. And again, we've got some canceling. Something at the top with something at the bottom. Remember, in this term, we are allowed to cancel because we only got multiplication and division. And now we have negative sine x times sine x. So that gives us minus sine squared x. And we know that 1 minus sine squared x is cos squared x from our square identity. Okay, so a mark on the reduction. This was out of 6. Definitely a mark on the tan identity. Definitely on that. Definitely on that. Definitely on that. 1, 2, 3, 4, 5. And then I think here the other mark that they would give us would be on, it depends on what they decide to do. They could put it in this first line, which would probably benefit students that are weaker, and maybe give a mark on the positive cos x and the positive sine x. I'm guessing that that's what they would have done in this case. Okay, so that's question 5.2. No. 1 minus 2 sine squared x is cos 2x. This is cos squared x. Okay, yeah. So you've got to be so careful, Tristan, in the way in which you write, hey, because you can have cos squared x, and you can have cos 2x. So yeah, you've just got to be very careful when working with double angles, that your 2 doesn't end up as a square, or that if it is cos squared x, that it doesn't end up as cos 2x, because that changes the meaning entirely, as you well know. Okay, so yeah, just be careful of that. Okay. Then there was also a request to do 5.4. So I'm happy to do that as well. Let's do 5.4. Okay, so question 5.4 asks us to determine the general solution to 2 cos squared x is equal to cos x. So this particular general solution is not actually as bad as some of the ones that they can give you. What you would do here is, because this is quadratic, is you are going to collect everything on one side and make it equal to 0. Then you're going to take out your highest common factor. And now you've got two solutions. So either cos x is 0, or cos x is going to be equal to 1 over 2. And now you'd have to find your PAA. So for cos x equal to 0, your PAA would be equal to 90. We treat 0 in this situation, we treat 0 as positive. So that means that you have to do a solution in quadrant 1 and quadrant 4. So either x is going to be equal to 90 plus k times 360. K is an element of the integers. Or x is going to be equal to 360 minus 90 plus k times 360. K is an element of the integers. So your other general solution is x equals 270 plus k times 360. K is an element of the integers. For cos x equal to a half, that of course is a special angle. So you know that your PAA would be 60. And again, your ratio here is positive. So quadrant 1 and quadrant 4. In quadrant 1, x would be equal to 60 plus k times 360. K is an element of the integers, or it would be 360 minus 60. So x would be equal to 300 plus k times 360. K is an element of the integers. All right, so important, when you are factorizing, don't leave off the equal 0. Very important. There would probably be an accuracy mark on your quadrants, your general solutions, 1, 2, 3, 4 quadrants. And then maybe a mark here, actually on both. 1, 2, 3, 4, 5. Maybe a mark for getting it into standard form. Okay, but as far as general solutions go at matric level, this is not a particularly difficult one. This is something that you would actually see in grade 11. If I was you, I would be expecting something that had compound angles or double angles in it, very, very definitely. Okay, so yeah, I mean, even the identity in this case is not a particularly difficult identity as far as identities go. So if you have a look at this question, this is one that I went and fished out from a past paper. I know you guys haven't seen this yet, but this is more the sort of thing that I would expect that they would give you at the bottom part of trig. So again, in 4.2, that is a grade 11 question because they're asking us to simplify it to a single trig ratio. That identity is definitely a little bit more complex. It involves double angles and factorizing. And then as well, if we have a look at 4.4, we've got a double angle in there. Not a particularly difficult general solution in that case, but it does have a double angle in it. And then, of course, in 4.5, there is a problem solving question. What I think I would like to do is give you guys an opportunity to take a screenshot of this. And I can do this again with you next week in session 2. How does everybody feel about that? I want to do slightly more difficult things with you because, yeah, I mean, it's not going to be easy. We're not expecting it to be easy. Is everybody happy with that? Okay. All right. So take a screenshot of this. I'll try and make it even bigger for you so that you guys can see it. And what's also cool about this particular question that I've gone and fished out is that it's also got a nice problem solving question in 4.5 that I would want to do with you. But I want to give you guys a chance to do this first on your own. And then next week when we do session 2, I'll start with this particular question. Okay. So at least you've got a week to try it. Okay. Has everybody managed to take a screenshot? Can I move on to the next thing? Because I think we might get pretty close to the end of this paper. There was only 105 marks here, not 150, but not that that matters. It's cool. All right. Question 6. Do you guys want me to do question 6 with you? 6.2. Okay, so does that mean that sketching these was okay? I mean, these are not difficult ones to sketch. So it's 2 sine x and cos x plus 30. All right, so we would need our sketch. So let me just grab that and put it on the screen. Okay, so when you sketch your graph, or graphs, should I say, it should have looked like this. So f of x equals 2 sine x is the one that is orange or sort of red in color. So this is the graph of f, and the yellowy mustard colored looking graph, that's the graph of G, the cos graph. So this is G over here. Yes, Simpiwe, you mean of the general solution? Sorry, guys, Simpiwe just wants. There you go. So screenshot that, Simpiwe. No problem, Simpiwe. All right, so let's just come back to this and we can quickly go through this. So use your graph to determine the values of x for which f of x times g of x is smaller than or equal to 0. Again, I think that a mark allocation here of 4 marks is probably a little bit much. It probably would be out of 2 rather than out of 4, but that doesn't matter. Okay, so when are multiplying y values together, they're just numbers, they're just output numbers. So our normal rules of multiplying integers apply in this case. If we want a negative outcome, which is what we want in this particular case, they have to be opposite in sign. So this one has to be positive while that one's negative, or this one has to be positive while that one is negative. So now we are looking, are the graphs, is one graph above the x-axis while the other one is below? Or vice versa. That's what we want. Okay, so where the y on one is positive and the y on the other will be negative. Okay, so we start off and they are both above the x-axis until we get to 60. Okay, so anything below 60 does not meet the requirements of this particular question. All right. So between 60 and then when we get to 180, F becomes negative. So at F, between F and 240, that also does not meet our requirements. So this is going to be between 60 and 180 because F is above and G is below. Then when we look at 240, G goes above whilst F is below. All right, so the next part is going to be between 270 and 360. Okay, so those are the answers there. And on an inequality, you only get 1 mark. Okay, everything has to be correct. You can only change the way that you write it. So in other words, if you want to write it like this with round brackets, in this case, that would also be acceptable. Okay, but you're only going to get 1 mark on each of those. All right, so that was the graphs. Okay, let's go and have a look at the Euclidean geometry. So when it came to question 7, is there anything here that you want me to go through? We probably would need 7.1 to do 7.2. Well, not probably. We do need 7.1 to do 7.2. Anybody want me to work through this? Question 7. Okay. Yes, please, both. All right. So, yeah, sorry, Tristan. I've got to do 7.1 to do 7.2 because, as you know, in geometry, everything that we've proved or calculated gives us what we need for the next question. All right. So, again, let me not make the same mistake I made earlier. Make sure you read the information properly before you get started on the question and just check that everything that they've given you is there on the diagram. So, there's not an awful lot here. They've told us that PQ is the diameter of the circle. So the minute we see the word diameter, we want to try and relate that keyword back to one of our grade 11 theorems. So what are you guys thinking when you see the word diameter? What does the word diameter link to you? That's it, angle in a semicircle. Good, Msomi, angle in a semicircle. Beautiful. All right, and we do exactly the same when we see the word tangent. Radius, potentially, yep, quite right, Nizole. Maybe in this situation we need radius perpendicular to tangent, but we would need tangent for that as well. Okay, so the minute we see the word tangent, we start thinking about tan chord theorem. Or if there are 2 tangents, then we would think about tangents from the same point. Not that that would apply in this diagram, but it could be that as well. Okay, and then very definitely radius perpendicular to tangent. Okay. Angle at center is twice angle at circumference. Definitely. Although in this particular case, I don't think we've got angle at center is twice angle at circumference. All right, and then they've told us that angle P1 is equal to X. So let's go and have a look at the first question. Here they've asked us to prove that P1 equals S. So if they've told us that P1 is X, essentially they're asking us to prove that S is also equal to X, aren't they? That's what it means. So somehow we need to show that this is also equal to X. All right, that's what they're asking us to do in this situation. So we're going to start, our starting point is with X, and we're going to say to ourselves, is there anything else in the diagram that we can see straight away that's equal to X? Well, W1 would also be equal to X, wouldn't it? Absolutely. But I don't think that there is any clear connection between W1 and S at this stage. So there don't seem to be any direct connections. Okay, so let's go back to the information. We know that this angle over here is equal to 90, don't we? Because of angle in a semicircle. And that means that in this circle over here, if that's 90, it means that this angle over here has to be 90 minus x. That's all we've got. So now what I'm doing is I'm now saying, okay, well, how is all of this related to S? Look here at the triangle. Okay, S is inside this triangle over here. I've got that angle. And I also know that this entire angle over here, even though this part is x, this entire angle here at P will also be equal to 90 because the diameter is perpendicular to the tangent. So if this angle is 90, this angle is 90 minus x, it proves that S is equal to x and hence equal to P1. Okay, so now what I've got to do is I've got to put that down on paper. All right. So what I'm going to say here is that R1 is equal to 90 angle in a semicircle. That means that Q1 plus Q2 is also equal, sorry, not also, is equal to 90 minus x, and that is because of the angles in a triangle. Okay. I'm also going to say that QPS is 90 because of radius perpendicular to tangent. And not that you need to write this, I'm just writing it for you. So in triangle QPS, we now have 90 minus x plus 90 plus s equal to 180. And that means that angle S is going to be equal to x. Okay, so therefore P1 equals S. Okay, because they both equal x. Does that make sense to everyone? Yes. All right, good. Our mark allocations, this is out of 4. So statement, reason, statement, reason, statement, reason, and then here, this would also be statement, reason. Okay, let's have a look at 7.2. Now they want us to prove that SRWT is a cyclic quad. Right now, sometimes these questions can be really difficult, proving that a quad is cyclic, and sometimes they can be really straightforward. This particular question is one of the more straightforward ones. Okay, so I always highlight the cyclic quad just to make it stick out for myself. And the first thing you should always do when they ask you to prove a quad is cyclic is recall the 3 reasons that we use to prove quads are cyclic. So it's either converse angles in the same segment, converse exterior angle of cyclic quad, or converse opposite angles of a cyclic quad are supplementary. If there is no bow tie inside the cyclic quad, it means we can immediately discard converse angles in the same segment, which is what we would do in this particular case, because there's no bow tie inside there. All right. If there's no bow tie inside, try and go with converse exterior angle of cyclic quad before converse opposite angles of a cyclic quad are supplementary. Okay, it's just the easier one of the two. All right. And in this particular case, we've actually already got our answer. Remember in the beginning, I don't know who it was now, but somebody's told us, let me just go back here. It was you, Lebogang. Lebogang said that angle W1 was equal to X because of angles in the same segment. So if we extend side TW, we can see that W1 is the exterior angle of the triangle. And because it's equal to X and S is equal to X, that's what makes SRWT cyclic in this case. All right, so thanks, Lebogang. You already gave us the answer. W1 is equal to X because of angles in the same segment. Oopsie, same segment. S is equal to X because we've proved that above. Sorry, that's an E. Sorry, my handwriting is terrible today. Sorry, that says proved above, even though it doesn't look like it. Let me just write a little bit nicer. Proved above. Okay, so that means that W1 equals S. Very important to write the angles that prove what we're trying to do here. Okay, so therefore SRWT is cyclic, and our reason is converse, exterior angle of cyclic quad. Marilyn, you can, but I don't know that that's actually going to help you. But it's good that that's what you understand that it means. Exactly, because proving a quad is cyclic means it's possible to draw a circle through the 4 points. But it doesn't necessarily help you with the answer. Okay, it's better to try and eliminate one of those 3 reasons and maybe just narrow it down to 2 of them rather than 3 of them. Drawing a circle around it is not necessarily going to help you. Sometimes, you know, when you prove a line is a tangent to a circle, sometimes people draw the circle around the triangle, but that doesn't necessarily help either. It's really what you're trying to do is identify the angles that are equal to each other that will prove it. Okay, so yeah, I wouldn't necessarily worry about doing that. Okay. Pleasure, Marilyn. All right, now marks it's out of 3. 1, 2, and then here, statement reason. Okay, but again, this is quite easy, this particular one. If you want, I can also find something that would be a little bit more difficult. I just didn't want to overload you guys, and try and do that with you next week as well. Okay, all right, question 8, we're getting there. Now, this is the question that I noticed in the memo. They use the words proportionality intercept theorem to prove this, but they didn't state the parallel lines. So very important. Remember, if you use proportionality intercept theorem as your reason, you have to state the parallel lines. They will be very fussy about that. Okay, so you will not get the mark. Even if everything is correct, if you've left off the parallel lines, they will take the mark away from you. So very, very important that that is there. Do you want me to do question 8.1? Yes, okay, not a problem. Cool. All right, so let's begin again by reading the information. So triangle MTS has A on MT and H on ST such that AH is parallel to MS. So straight away, we've got a triangle with a line drawn parallel to the third side. So we know we're using proportionality intercept theorem. They've told us MA is 18, TA is equal to 3x minus 15. And then it's only this little piece of information over here that we kind of need to navigate and figure out what that means. So if they're telling us that 5 of TH is equal to 2 times TS, if I made TH the subject of the formula, it means that TH is 2/5 of TS. So in other words, they're telling you that TS is 5 and that's 2. So the ratio of TH is to TS is 2 is to 5. Does that make sense? So it means that TH is to TS is 2 is to 5. Incidentally, that bit there would be 3. Does that make sense, everyone? Yes. All right, so now we can simply write TA over AM is equal to TH over HS. Proportionality intercept theorem, and then AH parallel to MS. You can go straight to subbing in, but maybe it's just a little bit easier for you if you write that down first. Okay, so now we'll sub in. So we've got 3x minus 15 over AM is 18. TH is 2 and HS is 3. And now we can cross multiply. So that gives us 9x minus 45 is equal to 36. So 9x is equal to 81. So therefore x is equal to 9. So statement, reason. I don't think this would actually be out of 5 either. I would put it out of 3. Okay, so statement, reason, and then the answer. All right, we've got 10 minutes left. Is everybody okay with question 8? All right. Okay, so yeah, we're going to have to, I will find some more difficult questions next week, and we will have to concentrate on those. Yeah, that's fine, Letu. So, that's not the proportion that I made here is not the only proportion that you could make. All right, so that would also give you the correct answer. Okay, I think the one that I did here is sort of the most straightforward one. Okay. All right. Question 8.2, do you want me to just sort of work through it from beginning to end? We've only got 10 minutes left. I don't know that I'll get to 8.2.4. Is everybody happy for me to do that? Excuse me. Yes? Okay, so 8.2.4, Cheslin, sure, fair enough. Okay, the rest of it is actually quite easy. So they've told us that CRKB is cyclic. We can see that it's got 4 points on the circle. They've told us RC equals RK. ART and SPU are tangents. Cool. So we're thinking about tan chord theorem, radius perpendicular to tangent, and not in this case, there's no tangents from the same point. And then they've given us 2 angles. B2 is 35 and B4 is 50. So in 8.2.1, why is B3 equal to 35? So it's because of these chords over here. So equal chords subtend equal angles. So this is a corollary of angles in the same segment. Does that sound familiar to you guys? Yes, all right. Now they want us to state with reasons two other angles that are each equal to 35. So we know that this is, I'm just going to put this in a different color. So that's 35 over there. So R1 would be equal to 35 because of tan chord theorem. And the same thing would happen over here with R4. R4 would be equal to this 35 over there because of tan chord theorem. All right, so these would be statement reason, statement reason. Now in 8.2.3, they want us to calculate the size of angle K2. What would be the quickest, easiest way for us to do that? I was thinking of exterior angle of triangle. That's only out of 2. Oh, it's going to be exterior angle of cyclic quad. Sorry, silly me. So your quad is cyclic. So let's just do, there's our cyclic quad, and K2 is the exterior angle of the cyclic quad. So the exterior angle of the cyclic quad is equal to the opposite interior angle. Okay, so that would be equal to C2. We don't have C2. For 2 marks. All right, so then in that case, oh, we can get R2. All right, let's do it like that. It is exterior angle of triangle. Okay, so I was right in the first instance. So it's 50, so R2 would be equal to 50. So it's this angle over here and that angle over there, tan chord theorem. Sometimes things are so easy, they're difficult, hey? And then K2 would be equal to 50 plus 35 because of exterior angle of triangle. Okay, so that means it would be equal to 85. That was part A. Part B, I think we're going to manage to finish this before. Yes, there we go. Angle A now. So that's up here. So we know that I would do exterior angle of triangle again. What I would do here is I would say that K2 equals C2. So C2 is also equal to 85 because of exterior angle of cyclic quad. And now that you know that that is 85, remember you've got R4. So if you subtract R4 from C2, that'll give you A because of exterior angle. Yeah, you could do it like that as well, Letu, no problem. Okay, so angle A is going to be equal to 85 minus R4 is 35 because of exterior angle of triangle. And that means that A is going to be equal to 50. All right. And then the last question, 8.2.4, let's just get this finished. They want us to prove that RB squared equals BK times BA. So now remember again, you're not allowed to write that on the page because that's what you're trying to prove. So in this situation, they probably want us to use similar triangles. So what we can do is we could figure out which triangles we are supposed to be working in by undoing what they've given us. Now, remember, we're not supposed to show this, all right? But what you can do is write that this is rough work, and then you can cross it out afterwards. So to get RB squared, we would have to have RB at the top and BK at the bottom, and then RB at the bottom over there and BA at the top over here. And now we're going to go across and we're going to say to ourselves, is RBA a triangle? RBA, yes it is, there it is. So here's RBA. And then we're going to go across at the bottom. Is BKR a triangle? BKR, yes it is. So let's do that in a different color. So BKR is this triangle over here. So that is our starting point, is in triangle RBA and triangle BKR. All right, so let's think about what we've already got. Okay, we know that A was equal to 50. And we've got this angle over here, which is 35. So we could work out what that angle R3 plus R4 is. And in this triangle over here, we know that this is equal to 50 and that's equal to 35. Okay, so straight away, R2 is equal to angle A. Angle A is equal to angle R2. Okay, they both equal 50. Okay, and we've got that up here. That's why we're allowed to say it. We've got it there and we've got it there. Okay. Then as far as the angles that are equal to 35, we've got angle B2, and that is equal to angle B3. They both equal 35. Okay, remember B2 was given, and B3 we've provided the reason for in 8.2.1. All right, so now in our third point, going back up here, angle ARB is equal to angle K1. And our reason there is angle sum and triangle. Or you can say remaining angles of triangle. So when you say angle sum and triangle or remaining angles of triangle, it cannot be your first reason. Okay, so the other two have to come first, and it can only be angle sum and triangle as your third reason, never, ever, ever your first. Okay, and now we just need to get the order correct. So therefore, triangle ABR is similar to triangle RBK. So our order is correct. This is very important. If the order is not correct in this line over here, you're never going to be able to create the proportions in the correct way. So that's very important. Then here we have to say corresponding sides in proportion, or corresponding sides of similar triangles in proportion. And now we can start. AB over RB is equal to BR over BK, which is equal to AR over RK. All right, now what did we want to prove? We wanted to prove that RB squared was BK times BA. So RB squared we'll get from here, and there is our AB or BA and our BK over there and over there. Okay, so therefore BR squared is going to be equal to BK times BA. There we go. It's done.